Okay, I think we have people sort of filing in, and we should be good to go. So welcome along, everyone. Just to quickly introduce myself, my name is Pranav. I am the head of the Customer Insights and Advisory team here at Plandek, and today I will be delivering this masterclass on metrics. This is the second of our masterclass series. The first one was run by my colleague Kier. The video for that is available on our YouTube channel if you'd wish to go and see that. And just so that you're aware, the video for this or the recording for this will also be posted on our YouTube channel once we finish today. But to quickly, just talk about what we're going to be doing here. Just a couple of housekeeping items before we get started. You should all see a Q&A box at the bottom of your screen. If you have any questions, please don't hesitate to ask, and I will get to them through the presentation today. And secondly, if you do need some closed captions, these are available for you as well. Okay, so without further ado, let me start sharing my screen and we will get going. So prepared some small slides for you to be able to. I promise you I won't bore you with a lot of slides today, just to quickly set the scene up before we jump into Plandek itself. So today's masterclass is going to be on engineering metrics. And in terms of the engineering metrics, what we're going to talk about is things like PRs, things like deployments, builds, etc. In terms of the agenda, I'm going to quickly just give you a small view of a typical CI/CD pipeline. We'll talk a little bit around the DORA metrics and why they're important and how they relate to the CI/CD pipelines. We'll then look to break down a popular DORA metric called as lead time for change. Then jump into the product to look at some PRs and how you can start to track these and look to improve those as you go along. And also looking at the different stages that will come within the time to deploy stage of lead time for change. So things like builds, things like tests, and deployments themselves as well. Okay, so looking at your typical CI/CD pipeline, you will, of course, this is not an exhaustive list, but there are the key stages which I'm trying to highlight here. You will have, you'll have your developers sort of doing the coding. Once the code is done and you've done the commits and the PR reviews, etc., and it has been merged into the code base, we'll jump into a build. So the build pipeline will run sort of to build your code, keep them ready to be deployed into whichever environment you need them to. Store the artifacts within as sort of secure repository. You then run some tests, some automated tests, for example, if you've pushed this into a pre-production or a staging environment, run some automated tests, do some end-to-end testing, which could be manual, which could be automated as well. Then finally, you would look to sort of deploy into production. Now, when we talk about the DORA metrics have been a very famous framework for measuring these CI/CD metrics. They are looking at a lot of these pretty much across the board, across these different stages. And as most of you might be aware of them, they are deployment frequency, lead time for change, mean time to restore service, and the change failure rate. But for today's purposes, for today's masterclass, I'm going to be focusing more on the happy path of things, so very much on deployment frequency and lead time for change. And what are the different sort of things that you can do to affect lead time for change? Look to break those down in the different constituent parts and talk a little bit about what are the different things that you can do either with Plandek and have look at these things to improve your processes to ultimately get to a stage where you have a lean, mean process going across your delivery side. When we talk about breaking down lead time for change, I like to break it down into two constituent parts, mainly being time to merge PRs and time to deploy. Now, within the time to merge PRs, you will want to sort of optimize the time taken from PR creation through to PR merge. And we'll talk a little bit around the metrics and how you can start to do these, how you can try to identify any potential issues or bottlenecks you might have. We'll then look to talk about the time to deploy stage and break this down a little bit as well. Because as I had mentioned, in the time to deploy stage, you effectively have the build, test, and deploy sides of your CI/CD pipelines. We'll look to talk about build success rates. You have to ensure that your build success rates are high. If you must fail, ensure that they're failing fast so that you don't end up losing a lot of time. Run your automated tests. Within Plandek, you have some metrics which you can use to track how much automated test coverage you have. And of course, finally, deploying it to production. So all of this will sort of end up providing you with your lead time for change, and how some tips and tricks are to follow in terms of how you can reduce this time down as well. So if you give me 1 second, I'll stop sharing and bring up Plandek. In the meanwhile, if you have any questions, please feel free to ask on the chat. And yeah, so I have this set up over here now. I keep the Q&A box open in case anyone's asking any questions on there. So, like I had mentioned, we have deployment frequency and lead time for change as two of your popular DORA metrics. I'm going to leave this one for now. Let's talk about lead time for change and look at the different constituent parts of lead time for change. So when we talk about lead time for change, in this case, I'm only looking at merged PRs for the matter. Not looking at anything which is either a closed or an abandoned or a canceled PR. With the time to merge PRs, you see that these are three different stages which we can provide you on Plandek. So ultimately, it's about understanding what you can do with this data to help you identify any potential bottlenecks. We're looking at this data at the moment, again, focusing just on time to merge PRs. What I see is that for this demo instance on Plandek and the data that we have, the lead time to approve for changes to PRs is roughly 9 hours. That's just more than about 1 working day. What that indicates to me is that potentially the PRs or the sizes of the PRs are too big. So there is a big difference between being able to merge a PR or having or creating a PR, which is of say 100 100 code changes, as opposed to 1,000 code changes. And keeping your PR cycle small will always ensure that you are getting through this cycle a lot faster. I've got one question here before we move on. So question from Emma is, how do we define deployed in an estate where releases are made to thousands of mobile devices? There can be a significant time difference between deployment to the first device and the last. Yeah, so in this case, we are typically looking at the first deployment here, Emma. We're looking at how long it takes to get from essentially code being written and finally merged and going through the entire cycle and ending up in a state where we're looking at the first deployment. If you would like to look at how you're deploying all the way to the last, the way Plandek works in this case is because you're sending us information for deployments. You're sending us information via the deployments API, and that can help you to relate to talk about when the last deployment was done as opposed to the first. And once we've had that, then there's ways that we can set up on Plandek for you to be able to effectively look at the time between the first to the last deployment. I hope that answers your question, Emma. Another question, for getting these metrics, we need to add build and deployment pipelines for Workspace, right? Possible to showcase that also? Yes, sure. Let me quickly show you. So what I've done in our Workspace over here, I have added 49 repositories, firstly. And within the build pipelines, I have selected effectively just to bring in all the build pipelines from all the repos added to this Workspace. Now, in terms of the deployments, this is very much dependent on the deployments that you're sending across to us via the deployments API. And that is essentially where you will start to see this information. So send us deployments. You can build automated processes to send us a simple pull request on the API after a deployment has happened. I hope that answers your question, Neelam. Okay, going back in. So where was I? Yeah, we were talking a little bit about PRs and how you can look to improve this measure. So keeping PRs sizes small would be the easiest way of doing it, ensuring that there's a good flow of PRs as well. If you keep your PR sizes small, you're able to get the approvals done faster. And not only that, the merging of the PRs would be a lot faster as well. If you can imagine a scenario where you are, say, a PR is raised on a Monday, and then the next PR is only raised the following Monday. The code base in that week's time could have moved on quite significantly. So what happens then in that scenario is that it might take you longer to approve the PR itself. And secondly, it might also take you a lot longer to resolve any merge conflicts, etc., as the code base has moved on. So keeping those cycles small can really help you be able to get through this process a little bit faster and ultimately affect your lead time for change and ultimately ensure that you are getting any of the sort of work getting through, ready for deployment, ready for all of the different stages that follow. Got another question. How do you handle non-working days, weekends? So there is actually a feature that we're looking to build out. At the moment, we don't handle non-working days because we've got clients all over the world, and weekends differ across different geographies, particularly in the Middle East. So it becomes difficult for us to understand which days are actual weekend days. Now, having said that, what we're looking to build is effectively a way for you to be able to tell us what your weekend days are, so that then we can exclude those from the calculations. So that's, at the moment, that is a slight limitation, but that is something which we're working on to help resolve. Okay, so just moving on. So sticking with PRs for the time being, what I'd like to do is, you might want to start thinking about how your teams are interacting with each other during the PR cycle. So a great metric for this, and we know that this is quite a popular one amongst a lot of our clients, is PR collaboration. What PR collaboration shows you and what you're seeing on your screen right now is effectively a metric of showing you a network diagram of of all of the engineers who are involved in the PR process and how they interact with each other. So you can see here that Jonas has participated in 10 pull requests, which were authored by Dimitris. It is giving you a good view of that, showing you how the people are interacting and where, if you have external dependencies where a PR is raised but has to be approved by someone outside of your team, you'll be able to track that within here as well. Now, a good way of understanding this metric and what you really should be looking for within this metric itself is that no one person has too much of a chunk of the pie. Now, the reason I say that is because if someone has too much chunk of the pie, say a quarter of the pie or even more, then they are potentially making themselves a single point of failure. So what happens if that person then leaves, is off on holiday or off sick, or at the worst case scenario, leaves the company? Then you are effectively losing a lot of your knowledge, and a lot of your knowledge goes away with them. So ensuring a good even distribution over here amongst your engineers can make a real difference in terms of ensuring that work does get through the PR cycles, not just sort of sitting and waiting for someone to come back. Again, over here, just in terms of the metrics themselves, I'm looking at just merged PRs. And I've excluded any bots from this as well to give you a view of how your people are interacting with each other in the PR cycle. Okay, talking about PRs again, some more sort of housekeeping things, looking at how you're adhering to different processes. Two more metrics which can really help bring that to life for you. One of these is commits without a PR. What I've done as well is I've broken down the data by repository to show you which of your repos have commits on them which don't end up being part of a PR. So a good way of understanding and maybe looking at certain issues which might arise from code, getting into the main code base without actually a PR being raised. So you can click into it and be able to see all of the commits themselves once that loads, and be able to see the time as well so that you can maybe look to start making some improvements to this process. Another one from a process perspective is PRs without a ticket reference. This one, again, really, really important from an audit trail perspective. Now, say you have a PR which doesn't have a ticket reference on it. What can happen is if something goes wrong, then it's harder to sort of roll back the information and you don't know which ticket it was related to, how you can then try to make some changes to that and have, say, suppose a bug or a defect results as part of a deployment into production. How you're able to trace that back very much depends on ensuring that there is good referenceability and PRs are going in with a ticket reference. A good way of tracking that again, to look at which repos there might be, is where you can see this, again, breaking the data down by repositories themselves. So this is, again, looking at sort of the process side of things and how people can affect the process and what you should be looking to have a look at during your sort of engineering cycles. Okay, so We've spoken a little bit about PRs. We've spoken about how you can start to track them and what the different stages of a PR's life cycle is, where you can maybe spot bottlenecks and how you can look to improve these as you go along. Let's talk about the time to deploy and what the different stages of time to deploy are. So as we had seen on the typical CI/CD pipeline, is that once a merge happens, typically it is followed by a build. Of course, you want to ensure that there is a good build success rate, and you're able to, there's nothing more frustrating for engineers that they've done all of the hard work, they've managed to get the PR sort of approved and merged into the code base, but a build then fails and then causes them frustration in terms of going back and resolving the issues. So a good way of tracking that is using the build failure rate metric, which I have set up for you over here. And what I've done as well is I have filtered by the master and the main branch. You have various other filter options available as well. So to look at a build pipeline or the repositories, if you want to focus on a particular repository, you can do that. But just looking at master and main, we can see that 20% of almost 21% of the builds fail. So 1 in every 5 is failing even on master and main, which might not be too bad, but improving this can really help this team get better and ensuring that they do develop faster and get the code through the entire sort of cycle a lot quicker than 1 in 5 builds sort of failing. Broken this down by the build pipeline again, so that if you're reviewing this and you want to make some changes and improvements to this process, you're able to identify which of the pipelines themselves are the biggest offenders and so it gives you an idea of what you need to tackle first. So we also provide you with the sort of numbers of builds as well within here. Clicking into any one of them will sort of bring across the details about them and whether they have failed or succeeded. So a good way of kind of seeing this to understand where your sort of build failures are and making some changes to improve your process going forwards. Now that we've spoken a little bit about builds, I did mention as well on the slides that you have to ensure that if builds do fail, that they fail quickly. Failing quickly ensures that you're able to maybe make some changes and get the build going again. So we have another metric called as your mean build time metric. This will track how fast or how slow your builds are. What I've done in this is I have just set the status as failed. And again, I'm just looking at master and main. So for this team, it takes around 14.5 minutes on average for builds to fail, which isn't bad. There's room for improvement here. You'd ideally want this down as low as possible. But if you start to see this going above 30, 35 minutes, then there is a serious problem, which you'll have to look to improve so that, if there are failures that do occur, that they occur fast, and then you can make some changes to the process and make some changes to the pipeline as necessary to make it go a little bit faster and obviously, hopefully succeed as well. Again, just the sort of times and the different builds are available on the metrics for you to view, make some analysis on the data, and ensure that you are improving this. Okay, so we've spoken about builds, we've spoken about build failures. Now, how would you look to identify, where the sort of, if you have a whole load of those builds going on, like where are the potential biggest issues within your code base itself? So we have this metric called as flakiest files, which can really help bring that to life for you. These gray circles that you see are repositories themselves, so individual repositories within the code base. The red circles within these are individual files. So the larger the circle means more number of lines which are changed within that file per pull request and then per subsequent build. The darker the pull request, the darker the red circle indicates how many failed pull requests happen for this particular file. So we can see here that this Python file is a big problem. 21 pull requests or 21 builds failed due to this file or resulted in a failure because of this file. And you have around mean lines changed per pull request of being around 78. So it indicates to us that, hey, this is potentially a problem. Like, let's go in, let's ensure that there's nothing wrong with this file and dig into the data, dig into our process to understand what could potentially be the problem here. make those changes to ensure that subsequent builds succeed, and then you're able to sort of rule out a problem. A key way of sort of identifying these issues is, of course, being able to look at them and to be able to see the data for this. And that's what we look to do with this particular metric for you. A couple of filter options available here in terms of looking at, say, you want to see just a particular type of file extension that you might have some problems with, or just looking at a particular repository itself. So a really good way of trying to understand how you can improve your build process, your build pipelines, which of your particular files are causing these issues, and how you can then make some changes to these, which you will know a lot more about within your code base, and look to improve this metric. Ultimately, that is going to affect your lead time for change. It's going to affect your deployment frequency and get to a stage where you are able to deploy as quickly as possible. Okay, so we've spoken again about PRs, we've spoken about builds. Let's talk a little bit about testing. In terms of testing, we have a great metric here, which is called as your active repositories metric. What I've done for this particular metric is that I have filtered by an issue type of bug, incident, or defect. So what this does is we're showing you a tree map of all of your repositories. And only repositories which have had bugs, incidents, or defects resolved against them. Again, a lot of this depends upon how well you are ensuring process or adhering to process, quite similar to what I had mentioned regarding the audit trails on PRs. It will just ensure that it is something where you are looking at these particular repositories, seeing where the potential issues are. Maybe there's a buildup of tech debt in a particular one. So we can see in this case, with the next gen repo, that there is 28 bugs, incidents, or defects which were resolved in here. Clicking into it, you are able to kind of dive into the folders themselves and be able to provide a different sort of view within here. Dive into them, see what the different tickets are, etc. Go deep into the folders themselves and understand what's going on. Got a question here. Yes, that's a really good point. Thank you so much for raising this. I'll take this back to our product team to sort of think about what else we could do, maybe some shapes within here that could help in terms of for people who might suffer from color blindness. Thank you for raising that. What is the difference between a bug and a defect? Well, it's a good question. So bugs and defects, we within this particular instance of Plandek, what we treat as bugs are something which might be raised during testing itself. So potentially in during your sprint testing or any of your end-to-end test integration, end-to-end regression, whatever it might be. Whereas a defect can be something which is found on production. So, typically what we do on our side is we would create an incident first as a first point of triage. And once that incident has been triaged and it is looked at as a valid bug or a valid issue, we will look to create that into a defect that can then be resolved by one of our team. So that's how we work at Plandek. But typically that's what we would call as a difference between a bug and a defect. I hope that answers your question, Boris. Okay, where was I? Yeah. So talking a little bit around the, where you can potentially find these issues. Now, you can go a step further as well with this particular metric. If you want to, be able to look at where the issues are happening, let's say it's happening at a staging environment, for example. You can then look to add some references on your tickets themselves, and then we'll be able to filter that for you to be like, okay, this particular bug was created, or if you want to see how many issues happened on staging that we were caught during our end-to-end or regression testing, then that's a really good way of doing this as well, where you're able to kind of understand which ones, sort of filter by the different labels, etc., and be able to dive down really into the particular issues that you might have. Clicking on this will show you the list of tickets as well. But one thing to remember in this case is that we will only show you repos which have had any of these resolved or closed. So that is the key difference over here that you have to remember for this particular metric. Another view within this metric is to sort of look at the top 10 files, like which files are the biggest offenders, which files do end up with a lot of issues within them in terms of bugs, incidents, and defects. You can see that an index.html file, sort of a UI issue potentially, where you have a lot of different tickets coming up for this. So a good way of kind of understanding as well, like which particular files are the problems that might cause over here. So quite similar to what we had seen with the flakiest files side of things as well. There are some other metrics available. Sorry, there's another question. Is this showing only open bugs or closed also? Yeah, Neelam, like I mentioned, it's only showing you resolved or closed bugs. We won't show you any open bugs in this case. It is predominantly just to show you things which have actually already happened, have actually already been resolved and closed. Okay. Where was I? So we have some, I was talking a little bit around the testing side of things. We have some other metrics which you can use as well. So things like, if you want to track your automated test coverage for your pipelines, then an easy way of doing this is to integrate with our time series API and send us that information on a regular basis. So say you want to, I don't have the metrics set up over here, but there's a really simple API to connect to. All you have to send us is a timestamp and a value. And that it will ensure that we are able to resolve these issues for you. You're able to get that information into Plandek and be able to visualize how your automated test coverage has changed. Another question, to have open so that it will help to detect defect analysis, and then team can take proactive actions for improvements. Neelam, so the problem with that, by the way, is that at this stage, the way we are able to relate repositories and defects is via commits. So, and typically you will have a commit or a pull request only once something has been, sort of sent across into the process and be able to bring those in. Now, whether we're able to kind of show you these open defects or not, I'll have to speak and sort of take this back to our product team. But it's a really good point to try and ensure that team can take some proactive actions for improvement. But it's likely that it will be a little bit difficult for them to do so if something has not been resolved already. There's a question from Jacek. Jacek, I'm sorry if I'm pronouncing your name wrong. Where can we find documentation? Yeah, this is available on our help website. So if I just quickly drop this in the chat for you, you can just go to help.plandek.com and search for the deployments API or the time series API. And that will provide you with that sort of information for this, for the different APIs. Okay, moving on. So we've spoken about, the code side of your CI/CD pipelines. We've spoken about the build side of things. We've spoken about the testing side of things. Now, finally, let's come to the final stage of the process, which is the deployments. So tying it back nicely with the deployment frequency. So of course, that's the first thing that you might want to track is how quickly and you are deploying or how frequently you're deploying. Looking at the DORA framework and the DORA reports, they always say that elite teams are ones who are able to deploy on demand. So they are keeping, ensuring there are smaller releases that are going through, that any changes that need to be made there's not a long release cycle effectively. And that's what we like to try and promote through Plandek as well, is something where you're able to track your deployment frequency, track how long things are going, and how quickly you're able to get your work from code all the way through into production. So a good metric for this is, again, using deployment frequency. And you'll be able to kind of filter with the information that you send across to us. I'm not filtering anything over here, but you're able to kind of see this in terms of your usual deployments and how quickly you're able to get this into production. Any use case where these metrics have realized benefits during the release? Yeah, I mean, if, for example, a good way of looking at it is if you are seeing your lead time for change, like if you are seeing that your PR cycles are very long, you're able to understand that, okay, there's potentially an issue. Where is there a bottleneck? Are people not getting to the reviews as quickly as possible? You will see a very large time to review effectively. So that's where it can help you realize those benefits again as an organization to ultimately be able to get your code into production faster. And that's the key sort of benefits where we have realized this. I mean, we see this amongst our own code base as well, like having used Plandek, understanding where the bottlenecks are, and resolving those bottlenecks has helped us ensure that we are able to get code into production faster and into the hands of our customers faster. So that's where these metrics can really help you understand where your issues are. I think that's a key point to make from my perspective, is that quite often you don't know where the issues are. So being able to identify them via data, and data will most likely give you it will 9 times out of 10 give you the right picture, and you'll be able to make some changes to try and help that situation. Okay. Coming down finally to another good metric which you can use is sort of looking at the time between deployments. Um, you can see that there was a bit of a peak over here over Christmas or New Year's. So where there's not a lot of deployments happening, of course, but again, to show you like how it's kind of like the deployment frequency metric itself, can show you how often you're deploying, how long it is taking between different deployments as well. So a really good sort of set of metrics for you to be able to understand your engineering process, your CI/CD process in particular, make some changes to improve these things. Does Plandek integrate with GitHub projects? When you're talking about GitHub projects, if you're talking about GitHub repos, yes, Plandek integrates with GitHub repos, but we don't integrate with GitHub issues at the moment. This is mainly, just from repository information, repositories and build pipeline information will come from GitHub into Plandek. Yeah, I hope that answers your question, GK. Okay, apart from that, just to quickly show you some of the other metrics which might be available, which I haven't added in over here. But if you filter in our metrics library with CI/CD and engineering, you can start to see a lot of different metrics as well. So build count, what your change failure rate is, of course, another key DORA metric. How often you're committing. We have looked at commits without a PR, deployment duration, how long your deployments take, as long as you're sending us that information via the pipeline, via the API. Flakiest files, lead time for change. We've seen all of these, but a lot of metrics available for you to be able to really drill down into where your issues are and how you can look to improve. That kind of brings us to the end of the masterclass for these metrics. I give another minute or so for any final questions from anyone. Okay, perfect. Thank you. Well, thanks so much for all of your attendance today. Really, really good to be able to deliver this masterclass to you guys. Hopefully, this will prove useful. Please do reach out to us, via the usual channels if you'd like any further support. We're more than happy to help you with these. Thank you again, and hope you have a lovely rest of your day.